Good day, future RMTs. Welcome back to our virtual classroom. In today's lecture, what we're going to discuss is all about the blood glucose determination, the test that we are going to perform, or the test that can be performed in order to determine the blood glucose determination. And for this lecture, our learning objectives or learning outcomes are as follows. Number one is to differentiate the methods of blood glucose determination, familiarize with the different reference methods or reference values of each method, and evaluate the test results and determine the clinical significance. Okay, so as we all know, blood glucose determination is one of the most important tests in the clinical laboratory setting or in the clinical laboratory because it will give us an idea of how is the metabolism or how the body responds in the mechanism or in the medication given to the patient those who are having a problem in the metabolism of glucose. Okay, so in this lecture, what we're going to discuss are the principles and how are we going to perform each test. Okay, so number one is chemical methods. I want you to take note and I want you to remember, guys, that the testing for glucose analysis can be divided into two major classifications. Number one is the chemical methods, and the other one is the enzymatic methods. For chemical methods, these are usually the methods that you perform already in your basic chemistry courses. Let's say, for example, the orthotolbutin method, the oxidation reduction method, which includes the Benedict's test, okay, are the tests that can be performed under the chemical method. So for chemical methods, we have the oxidation reduction method, okay, we have the alkaline ferric reduction method, we have the condensation method, and we have the orthotolbutin methods. Okay, so we are going to differentiate these four chemical methods, and to start with, we'll discuss first the oxidation reduction method. Okay, so from the word itself, oxidation reduction method, there is a substance that being reduced and substance that being oxidized because of the presence of oxidizing agent and reducing agent. Okay, I want you to take note, guys, that in oxidation reduction method, the main principle of this one is definitely the ability of our glucose, no, to directly reduce cupric ions into a cuprous oxide or cuprous ions. Okay, cupric ion into cuprous ion. Okay, and this test is performed in the presence of heat. Okay, as you still remember, no, yung Benedict's test natin, there is the application of heat, no, direct heat or a water bath will do. Okay, so that there will be a conversion of what we call cupric ions into cuprous ions. Okay, and then reduced cuprous ions can be formed into a cuprous oxide. Okay, so that is the major principle or the main principle of oxidation reduction method, which is true with Folin-Wu, Nelson-Somogyi, neocuproin, cuprion, Benedict's test, and Schiffer's method Somogyi. Okay, so let's discuss first the Folin-Wu test. Okay, I want you to take note that the Folin-Wu test is a glucose quantitatively test, now that reduces our cupric ions into cuprous ions in the presence of an alkaline solution. Okay, and then this alkaline solution oxidizes and consequently reduce our phosphomobilidic, okay, which is this one. Now which is added in this method, okay, to oxidize and back into cupric. Okay, so it will be oxidized, no, to back into a cupric oxide. So that is our the Folin-Wu. Okay, and I want you to take note that the reduced phosphomobilidic acid imparts a blue color which is read colorimetrically. Okay, so again, Folin-Wu is a glucose determination that quantitatively reduces our cupric ions to cuprous ions in the presence of an alkaline solution. This alkaline solution oxidizes our glycolic acid, and this glycolic acid can be found on our glucose. Okay, and then the phospholytic are oxidized back into cuprous or cupric oxide. So this is what is happening. No, as you can see in this one, this is our phospholytic MO6. Now it will be oxidized so that it can lose two electrons for our copper, so that our copper will gain electrons and therefore it will be back into cupric ions. And then no, this the reduction of our phosphomolybdic acid will impart a blue color which is read as calorimetrically or read in a calorimetric method. Now I want you to take note that in Folin-Wu, we are going to use protein-free filtrate preparation or PFF. Okay? What is the importance of PFF? In PFF, we are going to remove the proteins. Okay? Why we are going to denature the proteins? Why? We have to make sure that our blood sample is a protein-free filtrate preparation. Okay, the purpose of that is because take note, guys, that our protein has the tendency to interfere with many things in the reactions. Okay, during this test or during the test, and that's the very reason why we have to remove it from the blood. Okay, again, the purpose of denaturing our protein is to remove the proteins because the proteins has the tendency to interfere many of the laboratory tests. Okay, Folin-Wu and Nelson-Somogyi test, both of them requires or both of them requires no to have a protein-free filtrate preparation or PFF. Now, how are we going to or additionally, uh, the proteins that is removed during the preparation or during the protein-free filtrate, no, will be precipitated by anions, no, that will be precipitated by anions. Okay, so how are we going to perform a protein-free filtrate preparation? As you can see in these slides, so we have here our, I'm sorry, we have here our, where's my, yeah, we have here our Folin-Wu tube. Okay, this is a Folin-Wu tube used for the protein-free filtrate preparation. And as you can see, on the opposite of our Folin-Wu tube, we have degrees of colors, not, and that is actually the color reaction of our Folin-Wu. So the greater the color, it means the greater the number of carbohydrates or glucose present in the solution. Now, I want you to take note that Folin-Wu is read at absorbance for 120 nanometers, and the concentration or the units of Folin-Wu is expressed as mg per 100 ml. Therefore, this mg represents to the amount of glucose that is present per 100 ml of the sample. Okay, so the question is, how are we going to perform or how are we going to have our protein-free plasma or protein-free filtrate preparation? Okay, so I will share to you on how are we going to prepare our uh, protein-free filtrate, no, for our Folin-Wu. So the first thing to do is to add 1 ml, okay, 1 ml of distilled water, okay, in a Folin-Wu tube, okay, and then 0.2 ml of blood. Okay, this time you have only 0.2 ml of blood. Therefore, we are going to use our automatic pipetter. And if we're going to use our automatic pipetter, then we have to aspirate 200 UL, no, of our blood sample. Okay, having said that, now what we're going to do is after adding 1 ml of distilled water and 0.2 ml of blood, we have to add 1 ml of sodium tungstate. Now, the purpose of this sodium tungstate is to denature our proteins, no, because it will the anions, no, including the anions of this sodium tungstate will attract our protein. Okay, and then to remove our protein, we have to add 1 ml of 0.6 or 0. I'm sorry, 0.6 normal, no, 0.6 normal sulfuric acid, okay, which will serve as our catalyst. Now, after doing these things, then we have to filter our suspension or our solution and then centrifuge it. Therefore, and after that, we have already our protein-free filtrate, no, ready for the analysis. Okay, so that is the sample that will be used for our laboratory test. Okay, so again, the concentration of Folin-Wu is expressed as mg per 100 ml and it is read at absorbance of 420 nanometers. Now we have here the reference range for Folin-Wu. The normal or a condition or a body with a normal metabolism of glucose is expected to have 8 to 120 milligrams per 100 ml of blood. Okay, if your blood glucose level is seen at this level or at this range, therefore you are considered having a normal uh, glucose metabolism. However, if your glucose analysis is between 140 to 300, therefore we can say that you have a mild diabetic. Okay, so sir, how about the 121 to 130? That is the range wherein we consider it as a pre-diabetic stage. And if your blood glucose level in Folin-Wu is greater than or equal to 1,200 milligram per 100 ml of blood, you are considered to have a severe diabetes. Okay, so that is for our Folin-Wu. Aside from that, we have our Nelson-Somogyi method, and this method also uses our free protein-free filtrate, which is 1 is to 10 ang kanyang dilution. Now, take note guys that the proteinization or the deproteinized by or the blood is deproteinized by zinc sulfate barium oxide or barium hydroxide, okay, which gives the filtrate containing particularly no reducing substances other than glucose. So the main purpose of this one is to eliminate the interference that can cause an abnormal result or can give a false positive result because of the protein. Okay. Now take note people that the zinc barium filtrate is heated with alkaline copper reagent and treated with arsenomobylate color reagent. Okay, so that is the purpose why do we have or what is the principle rather, no, that is the principle of Nelson-Somogyi method. Again, the principle of Nelson-Somogyi method is to the deproteinized by zinc sulfate barium hydroxide, which will gives us a filtrate containing particularly no reducing substances other than our glucose. And take note that the zinc barium filtrate is heated with copper alkaline solution or alkaline copper solution and then treated with arsenomolybdate, which is our color reagent. So this is how we're going to prepare your Nelson-Somogyi method. You have to have a 4 Folin-Wu test tubes and each test tubes contain 2 ml of copper tartrate, which is our reagent, in a Nelson-Somogyi method. Okay, you're going to label it as tube B, tube C, tube S, and tube U. What does it mean? Tube B stands for this blank, no? Tube B means blank, tube C means control, tube S means standard, and tube U stands for our unknown, which is our solution or which is our sample, no? Our serum sample or our blood sample. Now, after adding 2 ml of our copper tartrate, which is our sample or our reagent, no, and 1 ml of each distilled water as a blank, no, sample control and standard, no. I am sure at this point in time you know what is the difference between sample control sample and standard. Okay, so after that, after adding this reagent and our sample, then we have to incubate our sample in water bath for 10 minutes. And then after incubating at water bath for 10 minutes, we have to uh, let it cool down by immersing it into a tap water. I'm sorry, by immersing it into a tap water for at most 3 minutes or 2 to 3 minutes. And then after that, we are going to add our 2 ml of arsenomobulate reagent, which is our color reagent. And then afterwards is we are going to mix it thoroughly, and then you are going to immerse it, or we are going to add 25 ml of water until to the mark of the Folin-Wu tube. Now, as we go on into our uh, face-to-face session, when time permits us, no, I will show to you, or we are going to perform this test. No, I will show to you what is Folin-Wu tube looks like. So we have Folin-Wu tubes in our laboratory, and then after that, no, after adding 25 ml on its immersion line or on its mark line, we're going to transfer it into a cuvette, and then we are going to read it at 520 nanometers ang kanyang absorbance. Okay, so take note again, Folin-Wu, ang kanyang absorbance is 420, and for our Nelson-Somogyi, the absorbance is 520 nanometers. Now, next in line is the reference range for our Nelson-Somogyi method. Take note, guys, that the unit for Somogyi method is mg% or 60 to 95% is the reference range for Nelson-Somogyi, or that is equivalent to 3.3 I'm sorry, 3.3 to 5.2 millimoles per liter. And how are you going to convert 60 mg% to 3.3 millimole per liter? We have to use the conversion factor 0.055. Again, the conversion factor is 0.055. Now, what are the other chemical tests that we have? We have our alkaline ferric reduction, and the principle of alkaline ferric reduction is the reduction of yellow ferric cyanide to colorless ferrocyanide glucose into alkaline conditions. Aside from that, we have our condensation method, which is the ability of the primary aromatic amine acid solutions to condense the aldehyde group to form glucosamine amine. Okay, and we have the orthotoluidine. Well, I believe that you are not new with orthotoluidine because I was able to discuss this already in our clinical microscopy class. Okay, this is actually the same principle, even though that we are going to have urine here, urine in CM, and serum or plasma here. That's actually the same thing, no? The same principle. Okay, that is glucose plus our orthotoluidine in the presence of our glacial acetic acid, which will produce our N-glucosamyl amine, which will impart a blue-green color, which indicates the presence of our glucose. Okay, and like what I've said, our glucose determination is divided into two categories. We have the chemical methods and we have the enzymatic methods. Now, if we are going to choose which of the two methods is much more uh, efficient or will give us a more accurate result, I will say, and I will be confident to say that enzymatic method is much more significant or will give us a more reliable result than our chemical method, because chemical method is just that is considered as a semi-quantitative method, or yeah, a semi-quantitative method wherein you have to read it into certain spectrophotometer or absorbance of spectrophotometer, and then right after that, you're going to compute first the concentration of our solution using the formula that will be given to you. Okay? And then usually, if you're going to use spectrophotometer naman, StatFax rather, StatFax, which is a semi-automated one, no, yun naman yun ay meron na siyang value. No? Yeah, chemical methods uses StatFax in order for us to determine the absorbance and the concentration of the solution from the transmittance of the absorbance. No, and then you have to compute it according to the formula. And then for semi-automated one, no, we are using the StatFax. Now, aside from that, we have the enzymatic methods, and these are usually the principles of the methods or the principles of the laboratory analysis involved in clinical chemistry section. So, for enzymatic methods, we have glucose oxidase and hexokinase. Well, I am sure and I am confident that at this point in time, you already know what is with glucose oxidase method because this is not the first time that you heard the glucose oxidase method, okay? If you still remember our discussion in clinical microscopy, the principle of our glucose strip is the double sequential enzymatic reaction which involves the presence of our glucose oxidase no that catalyzes no that catalyzes the glucose to gluconic acid and hydrogen peroxide, and this hydrogen peroxide will oxidatively bind with our 4-amino antipyrine or in the presence of our peroxidase enzyme. Okay, in the presence of peroxidase enzyme, this para-amino pyrethrin from our hydrogen peroxide will react with our peroxidase so that it will give us a quinoamine or quinoamine, which is a dye for our glucose oxidase method. Now, the concentration of our glucose oxidase method is usually read at 546 nanometer. Okay, 546 nanometer. A Folin-Wu 420, Nelson-Somogyi 520, and glucose oxidase method is read at 546 nanometer. Okay, and I want you to take note that the concentration for glucose method or glucose oxidase is set at 75 to 100 milligrams per deciliter. I repeat, the normal range for glucose oxidase is 75 to 115 milligrams per deciliter, which is equivalent to 4.20 to 6.40 millimoles per liter. Okay, and last but not the least is the hexokinase. I want you to take note that hexokinase is considered as the reference method for enzymatic determination of our glucose level. However, hexokinase is now considered as an obsolete test for chemistry for carbohydrates or for glucose. That's why the most widely used or the widely used na is our glucose oxidase method. Now, what is with hexokinase? Now, take note that the hexokinase reaction with our phosphoryl hexose and with our ATP, that is our glucose plus ATP, will give us our glucose 6-phosphate in the presence of our adenosine diphosphate. Now, take note that this glucose 6-phosphate will react with our I'm sorry, this should not be hexokinase, but rather this should be our glucose 6-phosphate dehydrogenase. Okay, I repeat, the glucose and the ATP will react in the presence of our hexokinase to give you a glucose 6-phosphate and our adenosine diphosphate. Now, take note that this glucose 6-phosphate plus our NAD or our NADP will react with our, this should be glucose 6-phosphate dehydrogenase or 6-phosphate dehydrogenase, which will react specifically with our glucose 6-phosphate to yield as 6-phosphoglucoactone plus our NADH, which is oxidized for the presence of our glucose. Okay, so ibig sabihin, the more the glucose is present, the higher the product we will have. Okay? Again, take note guys that our hexokinase method is our gold standard or our reference method for glucose analysis. However, it is now considered as our obsolete test. Okay? So I have here nice to know which I want you to take note and which I want you to remember. Orthofolwithin and Nelson-Somogyi test are considered as our chemical methods, which are both considered as an obsolete test. Hexokinase, which referred to be the reference method, is now considered as an obsolete enzymatic method, which is now considered as nowadays considered natin na most widely used enzymatic method is our glucose oxidase. And take note people that the difference between the enzymatic and the chemical method for glucose is expected to be at 5 to 15 milligrams per deciliter. Okay, that is the difference of our enzymatic and chemical methods. No, for glucose analysis, 5 to 15 milligrams per deciliter. Okay, so another point that I want you to take note is the whole blood sample is usually the sample for the point of care of testing or our POCT, which is done in the bedside, in home, in the office of the clinic or in the clinics of the doctors, no, using our glucometer. Usually that's whole blood or capillary blood. Okay. Also, I want you to take note. Well, I have discussed this. I am sure that I have discussed this already in our previous video, and I said that our whole blood gives 10 to 15% lower reading than our plasma. That's why it is recommended to use plasma or serum as our sample for glucose analysis. Why? Whole blood gives 10 to 15% lower than the plasma because there is a red cell that will require the glucose level so that it can undergo the metabolism because of the red cells that is present in our blood. Okay? Now, I am sure that you are all aware that if the person is having an IV transfusion or IV node, you are not allowed to extract blood on the site where the IV is located because of the contamination of our dextrose or the contamination of the IV fluid in the blood sample, which can lead into increase in sodium, most especially if the patient is receiving normal saline solution. But what if the patient is receiving dextrose, 5% dextrose? Take note guys, as little as 10% of the contamination of 5% dextrose in the blood will dramatically increase our blood level by 500 milligrams per deciliter. Could you imagine? You extracted blood in a site where the dextrose is being transfused or being given, and you extract blood, and the blood that you extracted will be used for the glucose determination. No, it will give you a increase of 500 milligrams per deciliter. Okay, and another thing that I want you to take note and to remember is sodium level in diabetes mellitus patient or diabetic patient is usually lower. Why? Because of the polyuria, no? The failure of our tubules to reabsorb our sodium because of the too much excretion of our water. As the water and sodium level is directly proportional to each other, as we all know, no, that affects also our uh, high blood pressure. Okay, now yeah, that's the end of our discussion. I just would like to add this one, fructosamine. I don't know if I was able to mention this to you in our discussion. Take note, guys, that fructosamine is used for the short term glucose monitoring. No, if HbA1c or glycosylated hemoglobin is used for a long term glucose monitoring, si fructosamine naman po ang ginagamit natin as our short-term glucose monitoring. Okay? So, That's it for our blood glucose determination. Okay? I hope that you learn and you gain an information on how you are going to perform and what are the principles of the glucose methods that is available for glucose analysis. Once again, thank you and stay safe everyone.